So for this setup, you have is it protons? Okay, whatever you're given. So we're going to assume they have equal mass. Their masses are identical. So you have one ball at rest, and then the other one coming to glance the one which is at rest, and then they fly off at different angles. Okay, so the sketch appears like this. You have the first ball coming to hit the second ball, and then it gets deflected at an angle of theta. Then the ball which was at rest as well also goes into the other direction like that, making an angle alpha with the original direction of motion. Okay, it's more like you are playing pool. Okay, so here we have to consider both. Since it's an elastic collision, we know that both momentum and energy are conserved. Okay, so we're going to consider the conservation of momentum and then also consider the conservation of energy. So in this case, the only type of energy we're working with is the kinetic energy. Okay, so conservation of momentum gives summation of momentum before must equal the sum of momentum after. So initial momentum must equal the final momentum. Okay, so we can write the conservation of momentum as this. Okay, which I'm sure now, but we know that the second ball is at rest. So actually this was meant to be u2. Okay, so we know that u2 is 0 like that. So if u2 is 0, then it means the initial momentum of the second ball is 0, and we remain with this. Okay, then also if we consider the mass of the first ball to be equal to the mass of the second ball, then we are going to remain with this u1 equals v1 plus v2, because the mass is going to cancel out. Okay, and then finally we cancel out the masses. We remain with u1 equals v1 plus v2 as our equation 1. Then notice that there is a change of direction here in this diagram. If we consider the original direction of motion as the x direction, then we have to resolve this momentum in components. Okay, we have to consider the x components as well as the y components of the momentum. So the x components of equation 1 here, we have u1 equals v1 plus v2. Now we are considering the x of this. We are going to have u1x giving us u1x giving us v1x plus v2x. If we consider the components from this diagram here, we are going to have that u1x is going to be v1 cos theta plus v2 cos alpha. Okay, that is the x direction. So we're going to have this here like that, and then we can have expressed in terms of v2 as being equal to u1 minus v1 cos theta. Okay, so this is our equation 2 here, simply resolving into components. And then the y component, we know that the initial y speed is 0. Okay, so we'll have u1y equals v1y plus v2y. But because our u1y is 0, we'll have 0 equals v1 sine theta minus v2 sine alpha. So for the second one, notice that we have a negative because it's heading towards the negative y-axis here. Okay, so v2 is heading towards the negative y-axis. That's why we have negative v2 sine alpha. Okay, so now there we go. Since we have a 0 on the other side, we can simply equate the two because the other one is negative, and we're going to have v1 sine theta equals v2 sine alpha. So this one is our equation 3. Okay, So now we're going to square equation 2 and 3 and then add them together. We square equation 2 and equation 3, then add them together, and we're going to come up with equation star in this form. Okay, so try it out. It's quite a long process here. So after squaring equation 2 and 3, we obtain equation star. So we end here. There's nothing much to do. Now we consider the conservation of energy. So since we are dealing with kinetic energy, we know that kinetic energy before must equal the kinetic energy after. Okay, so kinetic energy before equals that, and because the mass is identical, you don't even have to show it, keep showing it in the equation, because we know it's the same. So you only have half u1 squared equals half v1 squared plus half v2 squared. Okay, so on the initial kinetic here, notice that we didn't consider the kinetic energy of the second ball because it was at rest, so it's automatically 0. Okay, so the halves are going to cancel out again from both sides. We're going to remain with u1 squared equals v1 squared plus v2 squared. Okay, so after obtaining this, we can consider this as our equation hash. Okay, so this equation hash can be substituted into equation star, where there is u1 squared. We simply substitute this. Okay, so this is u1 squared. We're going to get this and then put here in equation star. Okay, after we substitute that, we'll be able to solve for v1. Okay, we'll be able to solve for v1, and then after solving for v1, we can come back to this equation hash here and substitute the value of v1 and then solve for v2. Okay, because u1 is already given as the initial velocity in the question. Okay, so we know what u1 is. We have just solved v1, so now we can also solve for v2. Okay, then to find alpha, we are saying okay, so let me just highlight this. So this other part you're going to do on your own. Okay, it's very simple. Just follow the steps in the in this video, and also these final touches here. So now we're saying, using equation number 3, find alpha. Okay, which is the direction of the second ball, or the second proton in this case. So using equation 3, this is our equation 3 over here. We have v1 sine theta equals v2 sine alpha. We know what theta is, and since we have solved for v1, we simply substitute those values here, and we also know what v2 is, then we can solve for alpha. Okay, so that's what you do for a question of this nature. All right.